Assalamu alaikum everyone. In this video I will discuss about writing a MATLAB code for load flow analysis. I'm considered that you all know the background theory of load flow analysis using Gauss-Seidel method. Here I am just showing you the algorithm for writing the code. We will use this A equation for determine the bus voltage, and we will use this equation for determining the generator bus reactive power. So here is the algorithm. We have nth buses, so first we assume the first bus as a swing bus, and to kth are the generator bus, and k plus 1 to n are the load buses. From the inputs we will find the admittance y bus, and after that we will calculate q2 to qk for generator bus using the equation v, and we will calculate v2 to vk using equation a. We will set the magnitude v2 to vk to the given value, but we will change the angle from the measured value. After that we will calculate the bus voltage for the load buses using the same equation, and we will check the del v. If the del v is not in the accepted limit, then we will repeat. Now I'm going to open MATLAB and start coding. For proper utilize the time, I am going to paste my written code here so that the time is utilized. Here is the code. So at first I'm sending the message to the user that we are considering first bus voltage as a reference voltage. Then I'm taking the input of the number of generator bus, then I take the input of number of load bus. So total number of buses will be 1 plus engine plus n load. So I'm sending the message that total number of bus is equal to n. Now I start a loop from 1 to engine plus 1 for getting the internal generator internal impedance. This section is for collecting the bus data. This is for real voltage of the swing bus, that means bus 1 voltage in per unit. This is angle of the swing bus, so the swing bus will be real into exp ij theta, so theta is del 1. In this section I write a loop for getting generator bus data. So number percentage bus generator voltage in per unit shows that the for when j is equal to 1, this will show number 2 bus voltage in per unit, that means bus voltage in per unit. So that will store in bgen j, and this will show that number 2 bus power in per unit, so that will store in pgen. Similarly, for j is equal to 1 to n load, I am taking the load data from the user, so that will show that number here I am showing that j plus n gen plus 1, that means after finishing the generator number, this will show number 3 or 4, that means the load bus number real power in per unit. This is showing that reactive power in per unit, so that those will store in p load and q load. After that, we take the input of the tolerance limit and send a message that if there is any reactive condition, then we took the input, and using this condition we take the input of maximum reactive power and minimum reactive power, like this. This section is for the line impedance. So we took a array. Using this loop we create a unique pairs of line. That means when p is equal to 1, j is equal to 2, p is equal to 2, then j is equal to 3, like unique pairs create by this loop. Okay, we took the line impedance, and here we took the line impedance for pj position, and we replace the same line impedance for jp positions. So if the line impedance for 1 2 line, then it will also place for 2 1 position. After ending the loop, the line admittance will be 1 divided by line impedance. Let's understand what we have done in this section. We took line impedance for pj position and placed the same line impedance for jp position, and we did not took any diagonal position line impedance for that. So if we look at that, we took 1 2 positions impedance. This will be same for 2 1 position also, but we did not took any line impedance for the 1 1 2 2 and 3 3 or 4 4 positions, so this will be 0. Now if we divide 1 divided by line impedance, the diagonal will be infinite, so this will give us the wrong answer. Here we create a loop for making the line admittance along the diagonal is equal to 0. After that, I create a matrix which is containing the input generator impedance, and other than the input generator impedance, all other generator impedance, internal generator impedance will be infinite. So I'm create this matrix using this command. As we know, the diagonal of the y bus is the summation of all buses connected to the uh, corresponding bus. So let me show you. The y bus is the summation of all buses which is connected to 1 2 3 4 respectively. So I'm doing this by using this command. Diag is equal to sum line admittance. Sum admittance will calculate the sum of the line admittance of a row, that means which is connected to line 1 or 2 or 3, and I create a diag matrix of generator impedance. After that, that will sum or add up with the diagonal matrix. So the diagonal matrix contain the line admittance and the generator admittance. Now y bus will be diagonal matrix minus line admittance. As we know, the value of this position is always minus, so I subtract the line admittance from the created diagonal matrix, so that will be our y bus matrix. This section is for assumption. We already know that the generator bus voltage is known, but the angle is unknown, so we have to assume that. Again, the load bus voltage is unknown. Similarly, load phase angle is also unknown. Here is these assumptions. After getting these assumption, we can create the bus voltage, all bus voltage. The first value will contain the swing bus voltage, and the middle arrays will contain the generator bus voltage, and the last arrays will contain the load bus voltages. After that, I create a real power array. The first value is 0 and the middle values are the real power of the generator bus, and the last values are the real power of the load bus. Let's go to the main code. Here I took the iteration from 1 to 20. This loop is for calculating the reactive power of the generator bus and calculating the bus voltage of the generator bus. So I start from 2 to 1 plus engine. This equation written from equation V like that, and after that I write the condition is exceed then the maximum value, then the maximum value will be replaced by the value of the Q. Similar condition for minimum, if the value is less than the minimum value, then this value will replaced by this Q value. So here I write this equation for calculating the bus voltage. The equation is Vi 1 Yi into Pi minus j Qi divided by Vi conjugate minus summation of k1 to n Yik Vk, where k not is equal to I. The next step of this algorithm is replacing the phase angle, not the magnitude. So the magnitude will remain same. Vgen k minus 1 means the positions of the generator bus voltage, and I use the new angle of the bus voltage. After that I calculate the del V by substituting the old value from the new value, and after that I replace the new value to the old value because I have to calculate the next voltages by using the new values. Here we already calculate the reactive power for the generator bus voltage, so we already know the reactive power of the load bus, so I took this value like this. This loop is for calculating the load bus voltage. I use the same equation to calculate the load bus voltage, and here I calculate the del V, which is substituting the old value from the new load bus voltage. Again I replace the new load bus voltage to the old load bus voltage. After that I calculate the absolute value of the del V. If the del V is less than the tolerance, then we need not to go further iteration, so we break the loop and we calculate the absolute value and the angle of the bus voltage. After calculating the line voltages, we can calculate the line current. The line current is the difference between the bus voltage divided by line impedance. So using this loop I can calculate the line current. Again I can calculate the power using this equation, which is P is equal to V I conjugate. So I calculate the IC line current from previous loop, so I can use this to calculate the power flow of the lines. So this is all about the code. Now I will show you an example how this code will work. So here we can see we consider the first bus as a reference bus. Number of generator bus, here number of generator bus is 1 and number of load bus is 2. Okay, So number of total bus is 4. Generator first internal impedance is 0.05 I, 0.08 I, voltage is 1 angle 0. Secondly, per unit, the generator 1.1 per unit. Here power is 5 per unit. The reactive power is -1 per unit, minus 0.5 per unit, minus 2.5 per unit, minus 1 per unit. Okay, the tolerance limit is 0.001 per unit. Okay, yes, true. Here is a condition. So maximum reactive power could be 15 per unit. Okay, minimum is equal to 0. Okay, line impedance for 1 I 13 is 0.05 plus 0.1 I 13, then 14 is 0.01, 0.125 I, 23 is infinity, there is no connection. 24 is 0.02 plus 0.125 I. Okay, 34 is 0.25 I. So our line impedance is given. Here is the calculations, so we can verify our code actually works or not. So this is the output. For here you can compare the value that is exactly same to the answer. So YBS is proved. Then the solution for iteration voltages, and this is the angle, this is the voltage. Okay, so we got 8 iteration. So after 8 iteration the answer will be 1.1 angle 13.87. so 1.83 1.1 13.87. okay, then the V2 then V3 will be 0.0933 minus 4.23, 9.9033 minus 4.23 minus 4.23. So we can see that the answer exactly same. Similarly, the power flow will be same. Here is the power flow. We can compare it with our solutions. So here is the power flow for for 1 2 bus. The real power is minus 2.664. Here exactly same. For 1 3 the real power is 0.92 0.9267, sorry, 76, and reactive power is 0.5268, 0.5268. So the code is absolutely all right. You can use this code for calculating the load flow analysis.